Hi guys, welcome to my channel. Today in this video I'm going to show a network simulation on 6LoWPAN and COAP protocol in Cooja network simulator. So let's get started. So I will start from the beginning. What is Contiki OS? Contiki OS is an open source operating system for the IoT, Internet of Things. Contiki connects tiny, low-cost, low-power microcontrollers to the internet. And Contiki is a powerful toolbox for building complex wireless systems. As I mentioned earlier, Contiki is an open source operating system. It was mainly focused for memory constrained systems having RAMs of few KBs with a focus on low power wireless IoT devices. Contiki provides multitasking using proto-threads method. It's a multi-threading program and have a built-in TCP/IP stack. Contiki OS needs only about 10 KB of RAM and 30 KB of ROM. Then Contiki provides three network mechanisms. They are UIP TCP/IP stack, 2 UIP 6 stack and RIME stack. UIP TCP/IP stack which provide for normal IPv4 networking, UIPv6 stack which provide IPv6 networking, and the last the RIME stack which is a set of custom lightweight network protocols designed for low-cost wireless systems. Next we will discuss about the hardware support of Contiki. Contiki is designed to run on types of hardware constrained in memory, power and processing power. As mentioned earlier, Contiki system has a memory in order of kilobytes only. Battery operated wireless sensors may need to provide years of unattended operation and with a little means of recharge or replace batteries. For example, Texas wireless sensor node's estimated system battery life is 10.5 years when measuring sensor value once per minute. So let us see which are the platforms which supports Contiki. So these are all the platforms supported by the Contiki. The primary platforms are of Texas Instruments and other platforms also listed in the website of Contiki. Most nodes are operating on a button cell that lasts for years. So next we will see what is Cooja network simulator. The Contiki systems include a network simulator called Cooja, which simulates networks on Contiki supported nodes. To run efficiently on a small memory system, the Contiki programming model is based on proto-threads. Actually, proto-thread is a memory efficient programming that feature of multi-threading to attain a low memory overhead. Next, we will see about 6LoWPAN. What is 6LoWPAN? Actually, 6LoWPAN stands for IPv6 over low power wireless personal area network. The 6LoWPAN concept originated from the idea that is the internet protocol could and should be applied even to smaller devices, and that low power devices with limited processing capabilities should be able to participate in the Internet of Things. The 6LoWPAN group has defined encapsulation and header compression mechanism that allow IPv6 packet to be sent and received over IEEE 802.15.4 based networks. IPv4 and IPv6 are the workhorse for the data delivery, and the local area network and wide area network such as internet. Likewise, IEEE 802.15.4 which provides sensing communication ability in wireless domain. It's the basis of Zigbee. In the figure you can see that several nodes which are connected. They are connected on a mesh network. So every nodes in the network are connected to the edge router. This is the edge router. They are connected over IEEE 802.15.4, and the edge router further connected to the internet. And the sensor values that are read from these sensor nodes are forwarded to this edge router. Then this edge router will forward the data to the internet. So the edge router will be acting as a bridge between 6LoWPAN network and the internet. So from the node it gets a message over 6LoWPAN and it translates and sends it to the internet through either Ethernet or Wi-Fi. So let's discuss about 6LoWPAN advantages. It uses open IP standard including TCP, IP, UDP, HTTP and CoAP and WebSockets. It allows mesh routing, that is one of the one-to-one or many-to-one, one-to-many routing. And its characteristics makes the technology ideal for the markets such as home automation with sensors, actuators and generic IoT applications. Then next we will be discuss about CoAP. Actually the CoAP stands for Constrained Application Protocol. It is defined in RFC 7252. CoAP is a specialized web transfer protocol for use with constrained nodes and constrained networks in Internet of Things. CoAP was necessary because traditional protocols are considered too heavy for memory constrained devices. CoAP protocol is that actually enables simple constrained things such as low power sensors and actuators to communicate indirectly through internet. It runs on devices that supports user datacom protocol and implements a lightweight application layer that features small message sizes, message management and lightweight message overhead, ideally suited for low power, low memory devices. CoAP model is similar to HTTP's client or server model. The border layer of the CoAP is the message layer that has been designed to deal with UDP and asynchronous switching. That is, our UDP is an asynchronous switching. However, HTTP is based on TCP protocol using point-to-point communication model that not suitable for notification push services. Also, for constrained devices, HTTP is too complex. So let's start the simulation. So first we need to download the Contiki. So for that just go to the website and just download instant Contiki. Just download Contiki instant Contiki 3.0. So wait till download finish. So after downloading the Contiki, just set up that Contiki to the VirtualBox. So I'm using VirtualBox. You can use either even VMware also. So I'm just starting my Contiki. The instant Contiki comes with Ubuntu 14.04. Just wait for a few minutes to set up that. So instant Contiki get started. So the default password for the instant Contiki will be the user. So it gets started. So we just need to start the Cooja network simulator. For that we need to get into the terminal and we just need to get into the folder. So the folder is on Contiki. We are using 3.0 and getting to tools Cooja. So for starting the simulator we need to enter this command and run. So this is a network simulator window. We can see that. So we need to start a simulation. So just go file, new simulation. You can just enter any simulation name. So I'm creating test_1. So this is the network window. In the window we can add modes, connect modes, and this is a simulation control window. We can control the simulation over this window, and this is the nodes window where we can add nodes if we need it, and this is the mode output. So every mode will be, the print statement will be printed on here, and this window is a timeline window. Through timeline window we can see at what instance the modes are reading and writing or sending data. So getting to modes, add modes, create new modes. So you can see this much modes are available in Contiki. So we need to choose which mode. So in this scenario I'm using sky mode, and you have to ensure that the selected mode supports 6LoWPAN. So sky mode supports 6LoWPAN. So I'm getting this. If you need description you can enter. I'm not going with the description. So here also the folder Contiki 3.0, and inside that example folder enter that IPv6. You can see the RPL border router and border router.c, and just clean it there and compile it. If the mode is not supported by 6LoWPAN, it will show error during compilation. So we can see that it's compiled successfully. So we just need to create. I just need one mode only, so I'm just adding one mode. So this is my one mode for so this green region, this is the range of this mode. I'm zooming it much more, and this gray region is the region where interference can be occurred. So green region signal quality will be good, and gray region signal quality will be bad. So the one mode I've set it as a RPL border router, and further I need to add mini modes. For that, go to modes, add modes, and go to sky modes. So in this case I'm using REST server. So go to REST example. So in Contiki 3.0, instead of REST, the folder will be er-rest example. So go to er under hyphen example, REST example, and select er example server.c. Clean it and compile it. So actually this program will implement COAP protocol. So you can see this combined successfully. These are warnings, so you can ignore that thing and creating. In this scenario I'm using 6 nodes, so it's random positioning, or otherwise you can choose manual positioning also. So I'm go with default options, random positioning. So you can see that my 6 modes have added. So here what I'm doing is, so mode 2 will be in the range of 1, and mode 3 will be in the range of 3, and mode 7 will be in the range of 3, mode 7 will be in the range of, similarly mode 6 will be in the range of 6, and mode 5 will be in the range of 2, mode 4 in the range of 7. You can position modes manually. So I align modes, then go to this router and go to more tools, go to serial socket and start that serial socket. So these all modes will establish a connection on 6LoWPAN. So we set up the nodes. So one will be the RPL border router, and the other 6 will be the servers. So they will collect data and they will send data whenever client access data. So this is RPL router and this is the servers. So for starting the simulation, just go there, open a terminal. Examples IPv6 RPL border, get into this folder, make connect router Cooja, password is user. So our bridge is ready. So whenever the data is coming through, serial will be transmitted to the internet. So now in this scenario, our web address with web server will be running on the localhost, that is 127.0.0.1. so I just minimizing it and I'm just starting the simulation. So you can see the address is even printed. So this CDS will be the server address. So I'm just copying the server address and I'm just opening a terminal. I'm just checking whether connection is established. So ping 6, I'm just pasting this address. So you can see that yes, it's pinging successfully. So I'm just connection has been established. So next I just want to verify the packets. The arrow mark is showing the packets, that is the nodes are being transmitting and using 6LoWPAN. So for that I just want to get into tools, radio messages, and in analyzer just select 6LoWPAN analyzer with PCAP. So this is the radio message window. I'm just making big and I'm just selecting a packet. So you can see that it belongs to the standard of IEEE 802.15.4. That makes the clarity that it's using SIGBIG signal, and further it's using IPv6. Then it's confirmed that it's using 6LoWPAN. So I'm just entering this server IP to the browser. So I'm just entering. So you can notice that. So this is the region of node 1, and you can see that node 2 only is within the range. So that's why you can see this neighbor, that 2 is in that neighbor list, and it shows the routing table like structure. So it's connected to every node through node 2. Now the 6LoWPAN is working. Now we need to ensure that COAP is also working. To check the COAP, in Mozilla there's plugin is available, add-on is available, that's a copper. So I already installed that copper. If you haven't installed, means just go to this and add-ons and just get add-ons. Just enter copper. Sorry. So this is the copper. So this copper is not compatible with Firefox content. So in this scenario I'm using old Firefox. If you have updated your Firefox, means you have to download an older version. So I already installed that copper. Then it will recognize the COAP protocol. So for that I just going to that 7th node. Just copying this. The format is, instead of HTTP we have to enter COAP : / and then our IP. So you can see that one COAP window is happening. Okay, then just press discover. So it discovers which all process available on this 7 node. So in our case these 6 nodes are programmed or compiled same program that runs 4 process: LED process, light process, and hello world process, and the button process. So when you're getting this light, so we can put the response through COAP protocol. So I want to know what the light value sensor value. I'm just getting that value. So I'm getting value from the server, that is CoAP server, that is running. So this will be my CoAP servers, and this will be the CoAP client. So the client will be getting from server as the light value will be 208:201. Similarly, for LED also, one LED process also running on this example code. So the 7 node, so I am showing LED on station. So you can see that 3 LEDs are off. So I'm going here, just go to toggle, this is one of the process. So I'm just posting a 0 on that. Let's check what's happening. So 0. So you can notice that red LED has on. So again I'm telling 1. So you can notice that my LED is off. So even check the hello process also, just get that always get hello. This is example code, you can customize according to our needs. So guys, that's the simulation on 6LoWPAN and CoAP protocol using Contiki Cooja network simulator. So thanks for watching my video. So don't forget to subscribe to my channel. Thank you.